Today I want to introduce you to the solderless breadboard. Now this piece of equipment will be what we will use to do all of our circuit prototyping throughout the remainder of this course. So if you're working with an Arduino or you're working with a Raspberry Pi and you need to build a small circuit to interface with one of these devices, then the solderless breadboard is your tool for doing that. One of the cool things about the solderless breadboard is the term solderless. So this allows you to connect components, electrical components, without the need of using solder and permanently connecting them to each other. And so the holes that you see on this device allow you to plug in resistors, chips, LEDs, switches, whatever you need, and connect them in your circuit and then move them around. So it's the perfect tool for prototyping circuits and learning about circuits. Okay? So, but before you get started using it, it's important that you understand how the thing is constructed so that you can use it properly and not make mistakes that are common among people who are first getting started doing electronic circuits, right? So I want to walk you through how the thing is built and how you should go about using it so that you can start building circuits on your own. All right. So the first thing that I want you to notice here is that along the left side, there's a bunch of letters. So we have A, B, C, D, E, F, G, H, I, J. So this indicates that there are actually 10 columns on this breadboard. Now I'm referring to those as columns even though I have the thing rotated to fit on the computer screen. Typically you would look at this to where the letters are facing you properly, and those would be columns of the breadboard. So think about those as columns. And then along the bottom of the screen you see 1, 5, 10, all the way up to 60. And likewise on the top, you see 1, 5, 10, all the way up to 60. And these are the rows of the breadboard. So if you're communicating with someone else or someone else is trying to communicate with you about where a particular component should be on the breadboard, they might use the term like D12. Okay? And if they did that, what they would be referring to is the D column and then the 12th row. And so see here highlighted in red is D12. Likewise, if they said H15, they would be referring to the hole that's identified there with blue. Okay, so you might be asking yourself, well, what about the 2 rows on top and the 2 rows on bottom that are marked with blue and red? Well, these are called the rails. And so the way that you'll utilize these actual columns is to bring in power and ground from an external circuit. So let's say that you're using your solderless breadboard with a Raspberry Pi. Well, the Raspberry Pi itself provides a 5 volt and a 3.3 volt power supply and ground pins. So if you always want the ground of your solderless breadboard circuit to match that of your Raspberry Pi, for instance. So you would want to connect a wire from the ground pin of the Raspberry Pi and then connect that to your solderless breadboard. And to do that, you're going to want to use the blue rail. And so this blue rail is all of the pins along this side that are all highlighted now in yellow. And so every pin along that are marked in yellow there are all electrically connected. And how do they do this? Well, the way this is done is that underneath the plastic of the solderless breadboard, there is a continuous piece of metal that goes all the way from the end where my mouse is currently located all the way to the other end here now shown in blue. And so there's one continuous strip of metal all along highlighting or connecting all of those holes that are highlighted in yellow. So if I put a wire where my mouse is now and put another wire here, then electricity could flow in one end of this wire all the way along the bottom behind the breadboard and then out to the other end here. Okay? And so what does this allow us to do? What this allows us to do is bring in voltage supply from the Raspberry Pi and ground from the Raspberry Pi, and then easily bring that into our circuit that will reside in the center part of our breadboard. Okay, so you never really want to build circuits out here on the outer part. You only want to use that outer part to bring in voltage and ground into the proper places within your circuit. And the same can be said for the bottom row. And so the bottom row, again, is all connected. The blue rail and the red rail are all connected, as can be seen there. But notice that the red rail at the top is not electrically connected to the red rail at the bottom. And this comes in handy because you might want to bring in a 3.3 volt power supply to one of your red rails and bring in a 5 volt power supply to one of your other rails. And so this allows you to have two different voltage rails on the same solderless breadboard circuit. Okay, so let's get to what's going on the inside. So each row is electrically connected, much like the rails are electrically connected. So if I highlight here on A1, you see that B1, C1, D1, and E1 are all highlighted in yellow. This indicates that all of those pins are electrically connected. And again, underneath the solderless breadboard, there's a single wire that's connecting all of those holes. So if you plug something into A1, it's connected to E1, for instance. Okay? But notice that F1 is not connected to E1, and that'll become important later, and we'll see why. But F1 is connected again along that same row with G1, H1, I1, and J1. And likewise, if we go to F5, then the 5 row on the right side is all electrically connected. Okay? And down the center, there's a gap. And this gap down the center is basically an insulator to keep the signals from the left side from being electrically connected to the signals on the right side. And why would that be important? Well, let's look at an example here. So I'm going to bring a push button like what you might use in your circuit, and I'm going to just place it down on the circuit. And notice that this push button has 4 pins on it. So it has a pin on each corner. And notice that I'm starting to see some green highlights here. So what this is saying is that the right side of the push button is connected to the row 7, and the other side is connected to row 5. And then you have this barrier across the middle where there's no connection. And now the other side is connected to the A part of row 5 and the A part of row 7. Okay? And then likewise, if we put down an integrated circuit chip, we'd have the same kind of thing, right? So you don't want to have pin 1 and 2 connected to one another just by putting them on the board. So this gap is a particular width that's just right for integrated circuit chips to fit across the gap and fit into the E and F columns of the solderless breadboard. And again, if we wanted to connect, say, this pin at the top left of the integrated circuit, that pin could be bridged with anything along here. Okay? So that kind of covers the grid. And so now if I wanted to, say, bring power from my rail to the bottom or the top pin 1, I could do something like this. Okay, and so now I have a wire that goes from the red rail to J15, And then J15 is electrically connected to F15. And so now I have power going to my integrated circuit chip. This is assuming now that I have this connected to some off-board power supply like my Raspberry Pi. And likewise, I would need ground off-board. So I'm going to color that wire black to indicate that that's a ground wire. And then ground on these chips is typically the last pin, if you're counting in this order. So maybe it would look something like this. But notice now this bottom rail of blue is not electrically connected to the top rail of blue. So one thing that you could always do is run a wire across to your two rails. And so now if I have ground coming in up here, it would be connected through all of these holes down to there, be connected across that wire, and then all the way back to here, and then to my integrated circuit chip. Okay? And so that might be how you would start, by bringing in power and ground to your integrated circuit chip, for instance. So that's basically everything you need to know to get started using the solderless breadboard system. And we'll return with more videos like this to walk you through how to build particular circuits and make measurements on this type of circuit.